Hello, Leon. It's your Zayde, Mason. I'm here today to read you Newtonian Physics for Babies. This is for you. Let's begin. This is a ball. It's a yellowish green ball, and it's a ball. And you can see it's in the air. There's a shadow. This ball feels the force of gravity. See? It's being pulled to the ground, just like you and me. We can't see gravity. See? It's not there. It is the force that keeps us on the ground, as I just mentioned. So we're on the ground, we feel gravity, and you can't see it. The force of gravity pulls the ball down. It pulls us down, it pulls everything down towards it. Ooh, a purple ball. Well, sort of violet. Okay, this ball is on the ground, see? And it's close to its shadow, so it's actually sitting on the ground. This ball also feels the force of gravity, even though it's also on the ground. The other one was in the air. This one's on the ground, but they both feel gravity. When it's on the ground, it feels the force of gravity, but it also feels the force of the ground pushing up on it. Strange, huh? Well, the force of the ground equals the force of gravity. If it didn't, it would move in one direction or another. The net force on the ball is zero, because if it were not zero, then it would either be moving upwards, away from the ground, and in the opposite direction of gravity pulling it, or it would be pulled through the ground towards the center of the earth, where the center of the gravity pulls us towards. It does not change motion. That's right, because its net force is zero. Ooh, a blue ball. This is also a ball, and it's in the air. This ball has a net force, and that's because it's not resting on the ground and nothing is pushing on it. So it's falling. See? Net force due to gravity. It does change its motion. It accelerates towards the ground because the ground is pulling it down from gravity. This ball, another ball in the air, and it's kind of greenish yellow, it has mass. Almost everything has mass. Oh, and this ball has more mass. See, it's bigger, and this ball has less mass. See how it's smaller, bigger, more mass, smaller. It's not always the case, but in this case, we are going to assume that they actually do have more mass based on their size. More mass, more force. See, there's a bigger arrow. Less mass, less force. So more mass means it has more force, getting pulled down even more, and less mass means it gets pulled down, but slightly less. Both feel the effects of gravity. The force of the ground, if they're sitting on the ground, always equals the force of gravity. So even if there's more force from the bigger ball because it has more mass, it still is being pushed on by the ground in an equal but opposite way. So there's more force from the ground on the ball if it's at rest, and there's less force on the smaller ball that has less mass. It's also being pushed up by the ground and pulled down by gravity. But if they're not moving, the net force is zero, and it's the same. This is Sir Isaac Newton, or a representation of him in a sort of ball form. Yes, everybody is sort of a sphere in physics. He wrote the 3 laws of motion. That's really cool. When this apple, and you know what an apple is, falls from the tree, it does not float away. It doesn't go upwards. No. It feels the force of gravity. It falls to the ground. It falls downward, like everything else. It gets pulled. Oh no! Isaac Newton got bonked on the head by an apple. Oh no! He felt the force of the apple hitting him on the head because gravity was pulling it down onto him. There's 3 laws of motion from Newtonian physics. The first law of motion, if an object has 0 force, it does not change motion. So we learned about that just now. If a ball is sitting on the ground and the ground is pushing up on it and gravity is pulling it down, the net force is 0 and it does not change motion. The second law of motion, The net force is equal to the mass times acceleration. Well, if the ball is bigger, it has more force because it's got more mass and it's being pulled down with more force. And if it's sitting on the ground has to push more on it to make the net force zero, to keep it with zero motion, like the first law says. And then finally, third law of motion, for every force, there's an equal force in the opposite direction. So, when the ball is sitting on the ground, if something's pushing on it from the ground, that is the ground pushing on it, and it is pushing on the ground, there's an equal but opposite force. Those are the 3 laws of Newtonian mechanics to start off with. Okay? Now you know Newtonian mechanics. Newtonian physics. So, there is today's lesson. I love you very much, Leon. I hope you have a wonderful day. This is your Zayde Mason signing out for now. I will read you another book soon, okay? Bye for now.